Hello and welcome back to the Tau Team update for April. And it's a development team update. So over to you, Karim, for your overview this month.
Thank you, Fola, and welcome everyone to the Tau development team update for the month of April 2026. Andrei has made some major architectural changes this month to the node process. He simplified the node by moving completely to the new Tau API with native C++ bindings, removing the older Docker-based model that was not very reliable. And he also introduced consensus time support and multi-output evaluation, which enables deterministic time-based rules and user-defined policy checks alongside built-in transaction validations. On the blockchain side, Andrew implemented canonical chain and fork choice logic with the reorganization support. And he updated the mining, replay, networking, and the web wallet to follow this new model. On the Tau side, David, as he explained in the Q&A session, he's been working on bit vector-related operations by trying to remove the bit blasting algorithm, or at least do as little of it as possible. And instead of bit blasting, replacing the bitwise operations by predicates that can be solved more readily using our high-level logic functions. So he's wrapping up those logistics now, doing some unit testing on them, and as soon as he's wrapped that up, he will be plugging them into the normalizer algorithm, which should hopefully result in some major performance improvements for bit vector operations. Lucca this month has concluded development of the BDD library for Tau expressions, and he is now on the integration of that library into the normalization algorithm. But he's always been spending a lot of time reviewing Ohad's latest research paper and having some intense theoretical discussions about it. It's also very interesting and entertaining for the rest of us to watch those discussions. Tomáš has been working on the Tau API, where he wrapped up a few finishing tasks, such as holding off on doing simplifications of logical expressions after every call, and holding off on doing any kind of type checking and type resolution until all the expressions have been submitted to the Tau runtime. And he added support also for timing each Tau API call, which was later used by the benchmarking module. And on the benchmarking side, he finished the timing of all operations, as well as creating a JSON output stream for all timing measurements. And he's created a shell script for collecting those timing measurements and recording them into files. Last but not least, Umar has been working on making the core Tau tree library multi-threaded, which hopefully will result in some major improvements in performance. He's been experimenting with different threading models that I had suggested to him, and running benchmarks comparing each threading model. That's it for the development team for this month. Fola, back to you.
All right, let's jump into the rest of the team for some deep dives. I'll pass it over to Lucca for his update this month.
Thank you, Fola, and thank you everyone for joining. So I started this month by reviewing the latest research by Ohad. And we had some discussion about it. And then I moved on, concluding the completion and the development of the BDD library for Tau expressions. These library differs from previous implementations that we had done in the past by the fact that it's tailored specifically towards the Tau abstract syntax tree data structure, so that you can very efficiently use it with Tau formulas and Tau terms. That's the goal. And one thing in which this library also differs is that operations have been extended to algebraic decision diagrams, because the leaves are not just true false. We did have this approach also in the past. However, for example, our advanced BDD end many operation, which can take an arbitrary number of BDDs and conjunct them very efficiently in one pass, essentially, has now been extended to these more general kind of decision diagrams, which wasn't the case before. And now that this library is usable, I'm integrating it into the normalization algorithm alongside many optimizations which we have been coming up with in the past, and now is the time to finally improve the normalization algorithm with all the theoretical work we did in practice, and we'll see some major performance improvements on this side soon. So thank you very much for tuning in, and I'll pass it back to Fola. Thank you.
Excellent. Thank you so much, Lucca. I'll pass it over to you now, David. Cheers.
Hi, Fola, and hi, everyone. This month, I've been working on the bit-blasting heuristics. The main idea is to replace bit vector-related operations by predicates in certain cases. The key point, as I mentioned in the Q&A, is to avoid the state explosion problem that bit blasting in general has. The main operations we are dealing with are addition, subtraction, multiplication, and so on by constants. The idea is to replace them by predicates that we could solve using our current methods. Usual logical operations, for example, are not replaced in our case because they are part of the, let's say, base logic that we use in our elimination algorithms. I'm wrapping up the code for the heuristics, and I want to write this code and check that everything is working properly before integrating it into the normalizer. That is the next thing that I will do. Thank you all for listening. That's all from my month. See you next month. And back to you, Fola.
All right, fantastic. Cheers, David. And over to you, Tomáš. Let's see what you've been up to.
Thank you, Fola. Hello, everyone. I focused on improving the DAO API. We need expressions to be simplified and type inferred when they are provided to some API functions, for example, normalization. So API should allow parts to have incomplete types, and these types must be transparently managed by the API itself when it's needed. So I've worked on this. And then I've added ability to measure each API call, measuring object. It can store measurements of subcalls as well. And I've added JSON command line option, or capital J, which enables printing of measurements in JSON. And then I've created a bench script which runs fixture programs and store the resulting measurements together with system information. And this benchmarking is going to be vital for future optimizations, so we can keep track of DAO performance over time. Recently, I've also fixed several issues in template instances, which we don't instantiate for DAO itself. So compile never tried to compile them, and so it has never encountered an issue. So I fixed several of these issues just today. So that's all from me this month. Thank you.
Awesome. Thank you so much, Tomáš. And, well, everyone wants to hear about the blockchain. So over to you, Andrei.
Hello, everyone. This is my quick update on DAO testnet alpha blockchain development. First thing I introduced is I got rid of the Docker weight of running DAO. Now DAO runs through direct bindings only. So instead of treating DAO as some external service, DAO is now wired into the node and is a part of it. It got us to a cleaner code and more cleaner approach to the node running. The next change is I I changed the model how the node and tau behaves. I introduced the consensus controlled timestamp with every block. It opened the possibility for time-based rules, and it's actually a huge step forward. And the other thing that I did, I added a multi-output tau processing. Before that, we had only one output that controlled whether the transaction go through or not. And now it can process multiple outputs. Specifically, I added a custom output that controls if the transaction goes on or not, that can be controlled by users, and users can now write rules to control the transaction behavior. Another major step forward was moving from a simple chain following the latest block to a complex fork choice mechanism. Now the node stores all forks and it chooses the correct chain deterministically. And also it can roll back if it finds a better chain to follow. And of course I had to wire everything from mining, peer-to-peer synchronizations, and mempool everywhere. I had to wire this new logic of fork choices. Also, I improved the web wallet with safer flows, with, of course, new example rules using time. Overall, that's it. What I'm working on currently is that I'm taking advantage of what tau brings us. I'm implementing a consensus mechanism that is controlled by blockchain users. So you could dynamically change the consensus mechanism of the blockchain. And I hope I will deliver it by the next month. So see you next month. Thank you. Take care. Bye.
All right, fantastic. Thanks, Andrei. Appreciate you. And last but not least, Ohad, talk to us.
I continued working on the paper, which includes the temporal extensions to the tau language. I had a setback. I found that I have some serious bug in my previous algorithm, but it seems like it turned out to the better. Working on this bug gave me a much deeper understanding of the setting of this new language. I think I have a fix for this, but there is still a lot of work in writing and analyzing everything.
All right, fantastic. Thanks, Ohad. And that about wraps it up from the dev team for April. Appreciate you all. Thank you so much for tuning in. And as always, you can find us on our socials. That's tau_net on X or Twitter. That's taunet AGRS on Reddit. That's our subreddit. And taunet, all one word, on Telegram. Cheers. See you.